mid-band in 6G. What are the machine learning technique in the 6G antenna design? Then we are going through that some of the antenna design or literature review on that which are using the machine learning algorithm. Then we can see that what are the scope. So what are the scope of this in that machine learning optimization technique in present antenna area. So this is basic of the microstick patch antenna. So as all we know that conventional antenna are basically volumetric antenna. So these antenna are known as a non-planar antenna. So as the different antenna, we know that dipole antenna, rhombic antenna, loop antenna, horn antenna, even the parabolic horn antenna. These are all are known as the volumetric antenna. So why it is known as the volumetric antenna? Because it having basically three dimension, the length, width, and height. So that's why it is known as the volumetric antenna. So these antenna are known as a non-planar antenna, as well as that another terms. If it is the planar type of antenna is there, so automatically the planar type of antenna is also are there. So one of the example that that particular term, that planar, basically planar antenna basically come under printed antenna technology, or we may consider it may be the fabricated in the PCB board. So why it is known as the planar? As it means it the circuit and antenna basically all are in the same plane. So that's why it is known as the planar antenna. So example of this planar antenna like monopole antenna in the printed form, the Vivaldi antenna, microstrip antenna. So these are all example of the planar. So from that figure itself, that from the figure one, if you can see that mainly the substrate is the sandwich between the ground plane and radiating patch. So the top level, this is basically that orange color, the top level, this is known as metallic patch. It may be that the different form, like it may be in the square form, or it may be the rectangular, triangle, disc, ring type of the different types of shape are possible in terms of the radiating. So we can see the substrate is basically sandwiched between the radiating patch and the ground plane, where the substrate having some dielectric constant. Normally it is used to within dielectric constant within less than 10 value, normally 2.2 for the Roger RD value. Also, if you see there is a dielectric constant, the width of the dielectric constant also can vary depending upon that application. It may be the 0.7 to 0.7 millimeter. Sometimes it's 1.57 millimeter, or sometimes it is the 3.175 millimeter. So we types of the thickness of the dielectric we can vary. So as we know that automatically to radiate or to get the radiation the antenna, we have to fit. So automatically to fit that particular antenna, we need that different feeding mechanism. So different types of the feeding technique are there. So one of the important feeding technique is known as coaxial feeding by the So is if we are going to do or apply the coaxial feeding, what happened? So outer conductor, if you means if you can recognize the coaxial type of cable, the coaxial basically outer conductor connected with the ground plane, and inner conductor of that so say that is a patch antenna. So we can say that the patch within that structure. Now we can consider here that patch, that is the particular the metal that heating plane and the ground plane we can consider as a perfect electric conductor, and that four walls, means four side walls, we can consider as a perfect magnetic conductor. So if you imagine that in patch is there and the ground plane is there, so this two is perfect electric conductor. And so so there is a possibility of resonance if we are going to launch some electric field. So automatically when we, by means of the coaxial probe, we are launching some electromagnetic wave. So what happened, it start resonating and resonating at particular frequency. So this is basically known as a design frequency. So uh, so as we know that standing wave due within that cavity. So what happened that when the electric field is launched, is basically we can see that electric field and magnetic field both are actually moving to and fro within the box, as we are considering as a cavity structure. So if it is a to and fro the within the box, so there is basically it will some split out from the box or patch periphery. If we consider that some it is one complete box, that because of that electric field or magnetic field is moving to and fro, so what happened from the periphery, some of the electric field will split out. So this is known as basically fringing effect, and that is the main reason of radiation. So here what we are considering, that top level is considered and ground level is considered as a PAC, and four side one we are considering as a PMC. So as we know that periphery of the patch, the maximum electric field. So why we actually consider as a perfect magnetic conductor. So at the periphery of the patch, we are considering that maximum electric field is there. So automatically, if the maximum electric field is there at the outer periphery of the patch, so automatically there is a minimum magnetic field. So we can say almost zero magnetic field. So we can consider that four wall treated as a PMC. So that's why four layer we are considering the PMC, and the two top layer and down layer we are considering as a PEC. So this is from the cavity. So as we know that cavity we can consider as a parallel resonating circuit that is a combination of the RLC. So this R, L and C can be connected in the parallel. So this is basically overall cavity structure. So overall microstrip patch antenna we may consider in terms of cavity structure. So we can consider is a parallel combination of the RLC, and to launch that electromagnetic wave, we have to apply some feeding. So if we are considered as a coaxial type of probe, so that connection, if you consider that we are a coaxial probe, inner conductor will be connected with the patch directly through the substrate. So this inner conductor is high frequency, normally we used to consider as a inductor. So if we are considered as an inductor, why we are considered at high frequency as an inductor? As we know that the inductance of uh, that inductive reactance, basically a conductor, is known as a J omega L. So if we increase the omega, so what happened? That frequency is also increasing. So automatically J omega L value is also increasing. So the inner probe we normally used to consider as an inductive or inductor. So that's why that normally the inner connection is used to connected with this parallel cavity structure, that is the RLC. We should connect one inductor. So this is basically one kind of equivalent circuit of the cavity resonator. So whenever we are considering as a coaxial probe, so there should be one in series, there should be one inductor, then in parallel that RLC value should be there. So these are the basic means how we can, means from the transmission model, we can calculate the width of the patch. And then we can calculate the effective dielectric constant as well as the effective length of that patch, length of the extension and actual. So these are all equations, these are all standard equations we can get from every book. So this is about that analytic transmission. Basically, we used to do the calculation, all those things in terms of the transmission model of the microstrip patch antenna. So this is a concept of the cavity model, which one I already discussed. So this is cavity model, and now the different types of the feeding mechanism. So as I already told, that the different feeding mechanism there to feed that antenna. So that one is, first of all, we can divide the feeding mechanism into category. One is known as the contacting, another is the non-contacting. So under contacting, as we can consider the coaxial probe feed and microstrip line feed. So from the figure itself, it is clear. So if you see that if it is the coaxial type of probe, that outer conductor is connected with the ground plane and inner conductor is connected through the substrate with that patch. So that's why it is known as a contacting. This is basically touching that the patch. So that's why it is known as a contacting. And this is an example of the coaxial probe feed. And this is basically microstrip line feed. So by means of this, one of that patch line, we can connect. So if you see, so this is one type of that. So it is also touching with the patch, the square patch. So that's why it is known as the microstrip line feed. And non-contacting, let us first complete under the microstrip line feed. So under this microstrip line feed, depending upon the position of the feed line, there is a different types of microstrip feed line structure. Feed line are there. So one of the example is the center feed. So it is basically the length of that, it is connected the center of that patch. Then offset feed, so it is slightly differ from the center. And this is the inset feed. If you see, instead of means, first we have to make one slot within that square patch, then within that slot we need to feed the microstrip line. And so this is the another way of feeding technique. So these are all inset, and then the quarter wave line. So main issue with this thing, basically we have to match. So as we know that for proper transfer of power from that load to source, automatically proper impedance matching should be there. So all necessary of doing basically impedance matching. So this is another technique to utilize the quarter wave line feeding. So here we are using the quarter wave structure to feed that your patch antenna. So this is another non-contacting technique. Here if you see that there is a aperture coupling is there and proximity coupling is there. So here if you see that mainly by means of the aperture coupling, in the ground plane there is a small slot. By means of that small slot, the electromagnetic wave is used to launched within that patch antenna. So that's why it is known as the aperture coupling. Whereas the proximity coupling, if you see, there is a gap between the microstrip line and within the patch. So in terms of this is basically one of the example of the non-contacting feeding mechanism. So this is overall feeding mechanism. So in so these are the different. So depending upon the different application and the requirement, the different researchers have done the different types of experiment that which feeding mechanism used to feed. So in terms of the microstrip patch antenna, a lot of people are working on the microstrip patch antenna, and that how to increase their antenna characteristics, how to improve the antenna characteristics. So out of them, that some of the, like by means of the deflated ground structure, slotted patch, also by means of the metamaterial like AMC, FSS, near zero metamaterial, DNG type of material. So they used to people are working on the characteristics, how to improve that antenna characteristics in that existing microstrip patch antenna. So now, as my topic is basically in terms of the FR3 band, so let me first explain that the 6G band. So nowadays that India is also working on that 5G and the 6G frequency. So research, I mean, the lot of research is going on this in terms of the 6G 6G communication. So as we know that the different spectrum, so it's mainly the 5G and that 7 gigahertz to 24 gigahertz is known as basically known as a mid band in 6G. So this band is one of the important band. So this is basically useful to provide KPI type of services. So KPI type of services like it is used to indicate that whether the service quality is improved service quality is providing by the telecommunication, or whether the customer experiences any network uh, um, means network degradation or not. Then it is also increase that operational efficiency. So this band is mainly provided that ubiquitous mobile ultra broadband, as well as it is used to keep that ultra high speed with low latency communication. So this is the main application of this band. So what are the basically advantages of this band? Why we are choosing this band? So basically this band why we are using, because this support that ultra high data rate. It also support that low latency, higher throughput, and it can increase the spectrum efficiency, enhance the data security, as well as it used to provide that energy efficient network. So that's why this band is important. So FR3 band, and out of this 7.125 to 24, 4.25 gigahertz is known as the FR3 band. Within this range, the 7 gigahertz to 15 gigahertz is basically known as a golden range of spectrum of in 6G. And so this is basically this range is basically support high data rate, and it can support that MIMO technology. Also, it can improve the coverage and capacity of telecommunication, and it having the less attenuation. So these are the advantage of this golden range of FR3 band, that 7 gigahertz to 15 gigahertz. So many research is going on within this and means within this frequency band, that many people are now trying to design antenna, that patch antenna within this FR3 band, and now they are trying to increase their gain and bandwidth, that how they can increase that antenna performance within this band, so it can be used for the 6G communication. So that's why we have chosen. So now we have to think about that what are because our basically our main objective to apply the machine learning algorithm to for design of the microstrip patch antenna. So as we know, whenever we are using the conventional way of design of microstrip patch antenna, so what are the basic steps are involved for doing the for designing and optimization of the microstrip patch antenna? So initially what we used to do, that is the first step, that design of a microstrip patch antenna using a traditional design equation. So as I already displayed those equation where we can calculate the width, length, desired frequency. So automatically you have to first find out that traditional design equation and desired frequency. So then next step, you have to identify the tuning required antenna design parameter. Then third step, then you have to that antenna design attending the desired result means you have to do some a permutation combination technique to attain that. So automatically that design antenna you have to simulate in the CST software or HFSS software to see that design parameter, which one we have the formulated, whether it is attained or not. Then we can do the optimization by means of that manual. So to get that optimal design parameter, then we used to do the hardware fabrication, then measurement and validation, that whether the validation is indicate that whether the fabricated result is similar as the software result or not. So this is the basic technique or conventional technique for designing any microstrip patch antenna. So then actually now actually our main theme is the machine learning algorithm in that 6G antenna design, or special we can say in the FR3 band, in a FR3 band. So whenever we are think about the machine learning, so basically machine learning technique is basically allow a computer, or we can say that in a model, to learn or make the decision without being explicitly programmed. So it's basically one machine, that machine, or with the, or we can say the computer, which can learn and it make a decision based on that input. So based on the training and input. So it's basically, it involves the feeding data uh, into that algorithm to identify the pattern and then make prediction on new data. So we can think as in terms of block, that first there should be the data, then that data will train the particular machine, or we can say that particular computer or particular model. So that's why it is known as the machine learning. So by means of those data, the training of that machine will possible. Then by that training, after completion of that training, that model will build. So there will be a model, then that model can predict that output based on that data by which the training has been done in that machine. So this is the four step, that the data should be there, then the training of the machine should be there, then after the training of the machine we can get the model, and that model now can able to predict the output. So why we are using the machine learning, means why it is necessity of doing the machine learning technique. So first of all, first technique, so what is the basically advantage? It is basically it helps to solve the complex problem. So why the complex problem is sometimes happen, that image, even the speech recognition in the healthcare. So these are the example of that solving the complex problem. Then it can able to handle that large volume of data. So like one example, the fraud detection in the financial transaction, it can easily detect. And then it can automate the repetitive tasks. So suppose you want to run that repetitive. So like this day in our Gmail, they are having the filtering spam mail. So automatically the Gmail is used to filter out that spam mail automatically. So this is the one of the example of the automated tasks. Then it can having that personalized user experience. Like you see that the different e-commerce site, like which one, if you search particular product, so automatically the relevant product or related product is used to come within that e-commerce site. So based on that personalized user experience, they used to feed you. Then by using your self improvement in performance, like self improvement, like presently if we know about that self driving car. So it's basically this actually one of the property, that is self improvement in performance. This property they are using. So by the self driving car, basically what they are doing, they are taking decision using millions of mile of driving data. So this is basically one of the example of the self improvement in the performance. So here main important parameter is data in the machine learning. So to get means proper performance from the machine learning, number of data as large as possible. So that what we can say, that what is the importance of the data in the machine learning, we can say that high quality and diverse data improve that how well model perform and the generalized to new situation or new solution. So large number of data, as well as that there should be the diversity of data. So it can help that model, or it can help to machine to recognize, or it can improve that machine to take a decision, proper decision. It also helps to model to understand the real world scenario, and it can adopt the practical uses also. Um, it sometimes it is required to separate data set for validation as well as the testing, because see, you have to categorize the two kind of data set, that for the training purpose you need to keep the data set, and then another for validation or testing purposes you need to keep the separate data set. So then also there is a required of the um, it means there should be some feedback mechanism. So data can be increased or model by that the model can be improved by means of the feedback loop. So these are the all importance parameter of data. It's about that data, why that different data is required. So mainly what we are dealing with, we are using the machine learning in the 6G antenna design to simplify of, or we can say that to simplify of the design and to get that optimal result, or to get that optimal antenna characteristics value after applying of the machine learning algorithm. But for that reason we need the large number of data, right? So in the antenna design, mainly in terms of the modeling of the 6G antenna, we are using the artificial neural network, as well as for the optimization algorithm we may use the particle swarm optimization and other evolutionary algorithm we can use. So first of all, that how we are going to apply the machine learning algorithm in FRC band or in the antenna design. So as we know that antenna properties like bandwidth, resonance, frequency, resonating frequency, or gain with the dimension of the patch antenna are basically determined by the through different simulation or by the equation also. So this is the basic thing. So once constructed the microstrip patch antenna, then you have to think about the data set. So to generate the data set, what you have to do, you have to do the parametric analysis of that antenna. So what we are going to do, once contrasted, this data set is divided into the training sets. As I told, that we require the different data set. That one data set is known as a training set, another is the cross validation set, and the test set that by using. So which is a proportional of each set according to the number of data entries. What we are we have to adopt. So initially people are trying the different type of algorithm and particular antenna design to see the performance of particular algorithm on particular design. So the main issue or the main problem of that machine learning method, data availability. So automatically the mathematical structure of the method all have an impact on the algorithm selection, and the model can be utilized for predicting output value for required input after training and testing. So afterward, that what you have to do, the different optimization algorithm may be incorporated to find the optimal design condition, and which can give best antenna characteristics like resonant frequency, bandwidth, or gain. So these are the basic steps are involved in that machine learning algorithm. So here the main issue that we require the large data set for incorporating of the machine learning algorithm in antenna design. So it is quite challenging also to create valid data set, since as we know, the single element basic antenna in electromagnetic simulation program like HFSS, CST take a long time to execute. So first of all, we need huge data set to get that proper optimization. So doing all those things is basically create one of the means it is one of the challenging work. So by using this machine learning in antenna design, we can improve the efficiency of the antenna. We can reduce the simulation time. Means initial time will large. Then after getting the data set, and if we train our model, then automatically it will help in the further optimization. Is used to reduce the simulation time. It can enhance that optimization capabilities Also, there is adaptability of the complex geometrical environment it is used to help. So these are all advantage of the machine learning if we are going to apply in terms of the antenna design. So what will be that particular flow chart of the machine learning based of antenna design? So if you see that this is a flow chart. So you have to first selection of the operating frequency, substrate, ground, plane, then patch material. Then you have to know that you have to calculate about the antenna dimension. So you are going to design and simulate by using the CST software or HFSS software. Then you have to do parametric variation that with that all the dimension maybe it's a related or not related parameter with that you have to vary to create or to create. So part also after doing this thing, you have to apply, you have to the optimization by getting the data set or after creating the data set, then optimization using the machine learning and performance analysis. So we have to apply that optimization maybe the different optimization technique. Then we are going to see that whether the simulated result which is basically obtained with whether it is the desired result, yes or no. So if it is the yes, then we are going for the hardware fabrication of that antenna using the PCB. If it is a no, again the similar procedure will follow. So then antenna measurement of that antenna characteristics, then we can do the comparison between the simulated result, optimize and the measured result. And then we do the validation of the design antenna and then aim. So this is overall flow chart of machine learning based antenna design. Now, as I told that in the different types of algorithm or different types of the optimization technique are available. So those all this all algorithm all means it's a known algorithm only we are going to be apply in antenna design. So one of the important machine learning algorithm is known as basically AANN. So it's known as basically artificial neural network. All of us we know. So what is basically where actually machine learning, as we know, that is basically machine or computer, which is determined for itself how input data is basically processed and predict outcome when provided with the new data. So basically, we can say that AN is basically a ML algorithm, which is based on the concept of human neuron or biological neural network. So as we know that the neuron are used to send the electrical signal to our brain. So similar principle or similar concept is applied in the ANN network. So this is the human neuron or biological neural network type. So as we know that every neuron is connected with other neuron through a connection link. If you think so, every neuron is used to connected with that other neuron through a particular connection link, and each connection link is basically associated with a weight and has information about the unit input signal. So this is basically weight vector, and neuron can solve a particular problem because the weight usually excite or exceed the signal that being communicated. So that output signal, which are basically produced after combining the input signal and activation state, maybe that may be sent to the other unit. So what happens? So that input signal will be received by that input vector. Then it will be through that information is getting by the activation. This is basically activation rule. Then we can send to the other unit. So particular decision can be taken. So if you see that here that in between that is the input and output, there is a number of hidden layers is there. So that hidden layers can be connected to each other, or we can say that normally in case of a human being, that one neuron to another neuron is connected with some connection or connection link, and that connection having some weight value or some actually understanding. So based on this, actually artificial neural network used to work. So it basically it has the number of forms like radial basic function, AN. So it is basically known as that RBF AN. Also, it having that gradient descent AN also there. The Livenberg Marguerite AN is also there based on how it learn and update the weight. So its weight value is one of the important value that depending upon that what will be the weight depending upon the input, then the decision is used to take by the also applying that activation network. So mainly we can see that radial basic function neural network is basically is a instance of the feed forward neural network, which having a 3-layer. That one layer is known as source node, another is known as the hidden layer, and that hidden layer is basically has that nonlinear Gaussian activation function and the linear output layer. So compares to that other conventional neural network, that researcher found that RBF network exhibit the better generalization capabilities and the faster training conference in slotted patch antenna dimension. So this is all about that. This is actually briefly I'm trying to discuss about that artificial neural network is also applied in the machine applied in that microstrip patch antenna design, or it's not exactly limited to the microstrip patch antenna. It's basically then different antenna design it may apply. So another of the optimization technique is known as basically particle swarm optimization algorithm. So before particle swarm optimization algorithm, let me ask from the audience, if you have any question or if you have any doubt, please please ask me. So in the meantime, if you have any issues.
Ma'am, there is one question.
There is one question.
Participant.
Yeah.
Is there any website available from where we get data set of antenna results to apply AI ML algorithm?
No, till today, like this, no means readily available data set are available. So from where we can collect the data set, because it's basically depending upon that particular antenna, because you have to create data set as based on your antenna. So it's not readily available data set or website from where you can collect the data.
Any more questions, participants? Ma'am, I think till now there are no more questions. They may ask later on.
Okay.
Yes, one more question, ma'am. How to create data for FSS designing and how much data we need?
See, how much data? It's like at least 90,000 to 1 lakh at least you require to design any antenna. So actually to predict the predict the machine, or we can say that we get the proper output if we have the large number of data, because you require the 3 set of data, that those data which is basically going to be used for training purposes, and within that data also there should be some diversity there, then only the training will be good. We can say that the training is good for that particular model. Then we can check with means for the testing data also we can data set we need to keep, and validation. So this data set may be just within the 10,000, 15,000 for training, means for validation and for the testing. So you can use like this, but for training purposes, you need to keep that number of data. And for any antenna, not necessary for the FSS, for any antenna, first of all, that whatever that antenna parameters, length, width, height, substrate width, so you have to do lot of parametric analysis. So based on that parametric analysis, maybe the resonating frequency is changing, the bandwidth is changing, so all thing will be considered as a, means those things you can consider as a data set. So you have to create your data set from actually one, depending upon that which type of design you are going to be implement. Okay.
Okay, ma'am. And the next question is, ma'am, how to create data for FSS designing? What all parameters do we need to take care of?
So the same thing that with particular for the frequency selective network, means for FSSs also, that distance between each unit cell. This is also one of the important parameter, the size of that particular unit cell. Then the unit cell means like dimension. So these are all important parameters. So you have to think about that, all you have to consider all the parameter and need to see that variation of frequency, bandwidth or gain. So this parameter you have to do the parameter, then only you can collect data set. Okay.
Okay, ma'am. We can continue the lecture, ma'am, now.
Yeah, thank you. So this is a particle example, the particle swarm optimization algorithm. So what happened with the particle swarm optimization? So this particle swarm optimization is basically a popular swarm-based global statistical optimization algorithm, which is developed by Kennedy and Russ Everhard and in 1995. So as we know that that this is particle swarm optimization, or we can say the PO. So it's basically a bio inspired algorithm, which is one of the example is just it is a basically simple on want to search for an optimal solution in the solution space. We can say that it is a one of the simple technique to search the optimal solution in a solution space. So it is a basically a different form of other optimization algorithm, it having only one objective function, which is basically new, means few hyperparameters. So that's why it is basically very easy. Means mainly different people are using that PSO also. So as we know that animal naturally share the information from themselves and with other member to their community. So suppose the bird, means if a bird are flying or individually for searching of the food or water or particular secure space where they can form or they can construct their nest. So what happened that initially the group of the birds will flying and trying to search all those all the facilities, like depending upon the requirement. And what happened that at least one bird can get the accurate information about maybe the food or maybe the water and resources. So what happened that one bird, means that bird particular going to be inform the other birds. So automatically what happened, the entire flux is going to be use that information and they can reach the particular food source. So basically particle solution, it is used to attempt improve that particular candidate, or we can say the particle solution, by iteratively by comparing it to the predetermined quality measure to optimize a problem. So it's a basically optimizes. It is used to help to find that optimal solution. So this is one of the example of that particle swarm optimization is known as also genetic algorithm optimization. So this genetic algorithm optimization technique is basically influenced by the biological evolution process, which is proposed by that J.H. Holland in 1992. We can say that genetic algorithm that simulate the process of natural selection we can say that the species that can adopt to change in their environment easily, and that those basically those can survive, means those species mainly survive, otherwise survive and sustain within the environment, and they can even go for the next generation. So in simple word, we can say that simulate the survival of the fittest among that individual of consecutive generation of the a particular means solving of the problem. So we can say that each generation is consist of a population of individual, and each individual is represent a point in such space and a particular possible solution. So we can say that each individual is basically represented as particular string or character or integer or float. So this type of string is basically analogous to, we can say that analogous to chromosome. So what we are going to say in that the genetic algorithm, so it having that the different procedure, it have that encoding, selection, crossover, mutation, and the culling procedure. So these are the all features or characteristics of the genetic algorithm. So this algorithm is, we are considered in terms of a set of solution or chromosome. So the fitness here, the fitness process or survival quotation is each chromosome is a population of proximity. So we are, by means of the genetic algorithm, we are trying to find out that best possible, or those who are survived, then it can next means it can possibility. So it is basically analogous to that particular. So several gene like modified or mutation like could or maintain the genetic variety among the population. So that variety and this type of concept is utilized in this optimization technique. Another algorithm, this is also part of, is the PCO technique only. So this technique is also known as ant colony optimization algorithm. So suppose that ant colony optimization algorithm, that if you consider the like the two possible paths. Suppose so this is basically ant colony, means you have to think about, suppose here um uh, here we know about that pheromones. So go from one place to the another place. So what happened? They used to emit that pheromones, and by these pheromones, actually, that another ant which is can recognize that which is going to travel that in front of them, so they can recognize that in which path they are moving. So if we consider the two possible paths between the food source and the ant nest. Suppose we are considering next of the ant and the food source, and we are considering one the straight path and another is the curvature of the path or curved path. So we are assuming this the curved path, that food of the ant and the nest of the ant. So what are the states? So initially, what happened, that if you consider that all ants are in initial, the first step, or the all ants are in the next. So what happened? There is a no pheromones contained in the environment. So this is the first condition. Then stage two, what happened? That ants going to be begin their search with equal probability, like 0.5 probability along each path. So consider the two paths. We are considering the copper curved path and the straight lining path. So if we consider that curved path automatically is a longer path, so automatically time taken by the ant particular to food will get get the longer time to reach. Or the step three, what will be the step three, and which the ant which is basically gone through the shorter path and reaches the food earlier. So what happened? So when they reach the early, so automatically the pheromones will be there. So that the path is also indicated by the pheromones. The car pheromone, but the information, what is the probability of this selection is higher. So what happened? The step four, what happened? That more ant, as we know that ant also communicate to each other, what happened that more ant will return via the shorter path. So automatically what happened that in the pheromones will high at the shorter path. So this is the basic concept of the ant colony optimization technique. So due to this evaporation, what happened? The pheromones level of the larger path will reduce and decreases the probability of selection of this path in the future stages. So this whole colony gradually uses the shorter path in higher probabilities. So this is the path optimization. The path optimization is obtained. So this optimization in technique also can be used for antenna design. Another technique is known as that chameleon swarm algorithm. This is also a part of the PSO algorithm. This algorithm is basically based on the hunting behavior of the chameleon in mainly desert area by MS Branik in 2021. So as we know that chameleons are the quite unique and specialized, or it may come that in the different species which can change their color to fit within that particular environment or surrounding environment. So it having that chameleon have that unique visual capability that it is used to see up to the 32 feet in front of them. Also, it can turn over their head by the 360 degree or their eyes by the 360 degree. So what happened during the predation? So what happened? The sticky stung of the chameleon chased the prey and from a little sanction curve which having the speed of the 2590 meter per second. So this feature is also considered as an objective function of that chameleon swarm algorithm. Another algorithm is the gray wolf optimization algorithm. So this is gray wolf optimization algorithm is also that, as we know that gray wolf, first of all, this is having that hunting behavior. It is basically introduced by that Amir Jalili at all, introduced 2004. And when the gray wolf see the prey, what happened? They start tracking and encircle it. Means actually gray wolf is always used to stay in the group. So it's not the group of wolf is used to stay tracking that particular prey, and then it used means all gray wolves. So what they used to do, they used to distract the target and then preventing that if nothing is going on, then they used to attack that particular prey. So this is like unique function is used for the attack purpose. So it having basically what are the main phases of this the gray wolf optimization algorithm? It having the tracking, chasing, and approaching the prey. It also the pausing, even encircle and harassing the prey until it's stop moving. So automatically the prey is confused and it will stop its his moving. So afterward it can attract to particular prey. Another technique optimization. So like this, the many technique are there. Here is the moth flame optimization algorithm, which is proposed by the Mirjanil in 2015. It is also inspired by the moth. As we know that at the night, what happened that a fly is used to fly straight towards the moon, or it is flying the spiral path to arrive at a particular light. So this is the main concept of the moth flame optimization algorithm. And there is also one algorithm that is also based on a necked mole rat. So that concept was concept is also based on that swarm intelligence optimization algorithm, that is a behavior and colony basically in terms of the necked mole rat. So this is about the necked mole algorithm. So hybrid. So presently what happened, instead of utilizing a particular optimum technique, or whenever we are thinking about the antenna design, the many people what they are trying to do, they used to basically combining many optimization technique, and they are trying to means select that best thing of the particular particular optimization technique, and that they are combining the features, and they are used to generate that hybrid optimization technique. So the what are the basically get that better result. So it basically mitigate their weaknesses, and it can get the better result. So these are all optimization technique used in antenna design. So whenever we are think about the antenna design, one of the important parameter is known as return loss. So as majority antenna people know, 1 minute. Sorry. Uh, Let me start about the return loss. So here from the figure itself, you can see that a return loss is normally defined as one parameter, which is indicate the 10 log of 10p in by the p reflected. So what happened, that high return loss is basically indicating the low reflected power, and basically it is basically transfer the data majority of power from that source to load side, that high return loss. And if it is the low return loss, is basically indicated that majority power is reflected back to the sources. So it is obvious that whenever we are doing antenna design, that S11 parameter means we always used to see the S11 parameter, the return loss. So if you see that that high return loss is obvious, it is required to design a good antenna. So now we will going to start that the different types of antenna design in terms of the different machine learning algorithm, that what are the algorithm we have used. So the first antenna that is proposed by that Verma et al. Uh, it's basically, if you see that it is a nothing but a rectangular microstrip patch antenna with T shape. So if you see that there is a T shape slot is so T shape, which is basically utilizing the they have tried by using initially conventional optimization technique. Also, they have applied that particle swarm optimization technique with curve feeding. So what happened with this PCO? They have used basically PCO to optimize that patch variable parameter. So what they have done, the bandwidth of the proposed patch antenna, they have actually targeted to increase the bandwidth. So for that reason, the optimization of the patch antenna construction has been studied using the PCO execution. Then they have done that card feeding in that MATLAB. Then means actually the PSO algorithm they have implemented in the MATLAB. And for antenna modeling and card fitting, they have used Graph-Matica software and IE3D simulation program. So this is the means the main software they have used. So here they obtain that experimental impedance bandwidth by using that PCO optimization antenna. They obtain around 42.59% in the frequency range of 2.07 to 3.19 gigahertz at with a return loss. If you see that with a return loss of 39.198 dB. So in this figure, actually they have drawn that the experimental result. The green color is the experimental result. Then they have applied the PCO. The PCO is basically red color, and this is a conventional result. This that black color. So if you see that compared to the conventional current, they obtain the return loss in that by applying that PCO optimization technique. So similar, this is one of that basically design, or they have utilized that PCO technique in their microstrip antenna design. Is a basically rectangular shape. And another thing that is the in the 32 reference is basically Vilovec et al., which is basically 2013 paper. They have also designed rectangular microstrip patch antenna with a resonating frequency of 2.45 gigahertz. They have used a dielectric constant of 4.5 and with a height of 1.5 1.588 millimeter. So what algorithm they have used, basically they have used here also the particle swarm optimization they have used. And this antenna is basically created based on the result of neural network is this is also that the use of neural network, actually they have used the radial basic function to determine input impedance for different feed position. So here if you and actually microstrip feeding, that micro that they have changed that position of the microstrip feeding, and they have applied to determine that optimum the feeding position. So that algorithm is known as the radial basic function neural network they have applied. And they also compare that antenna also fabricated and to the measure, and they compare with the measure result with the simulated results. So what they found that measured antenna value are compared with the finding neural network calculation. So here the MAC value they obtain that 0.104. Next paper, which is proposed by the Sarma et al. So this is also that square patch antenna, um, which is designed by substrate RT Duroid RT6002 with height of 1.6 millimeter within a frequency band of 0.4856 to 7.8476 gigahertz. So here, what they have done, they proposed is basically regression-based machine learning approach to compute the resonant frequency at a dominant mode of TM10 and the slot dimension of the square patch and the patch dimension to compact microstrip antenna in a frequency band of. So they have basically obtained the frequency band of by this antenna is a 0.48556 to 7.8476 gigahertz. Actually, what they found, they have checked that by means of that RMAC for prediction, the resonant frequency, the slot length, patch length, they have taken that the different value, which is basically helps to the Gaussian process regression to get that efficient value of design of compact microstrip patch antenna for various applications. So this application like VHF, ULF, L band, S band, C band. So for that reason, they have done the parametric analysis to get that data set depending upon the dependent and non-dependent variable. They, as I told, that the different parameter they have utilized to get the lot of data set. So different algorithm, if you see that different algorithm they has used like linear regression, tree regression, ensemble regression, support vector machine regression, Gaussian process regression, AN based for optimization. And for doing this, they have used the MATLAB, and as well as that the particular antennas are fabricated in that fabricated as and as well as they compared with the simulated result. they have basically done around training by the 3620 data sample from the data set, where the 202 data is mainly they have used for the randomly selected data for sample to data. So if you see that they have utilized that not many data set, as I told that for training we require a lot of data sets. So they have utilized only for almost 4,000 data for training purposes. Next, Ranjan et al. So here the Ranjan et al. In 2022, they have designed basically a compact coplanar nozzle, have also fabricated in the band. Uh, they utilize five distinct the machine learning algorithm like decision tree, random forest, XGBoost regression, K nearest neighbor, and artificial neural network. So to obtain the data sets, what they have done, uh, uh, they have actually varying the length, width, and the thickness of the L-shaped slot. So if you see that here is a L-shaped slot is there. So this L-shaped slot, they have varying that length, width, and thickness of this L-shaped slot after the machine learning model have been trained using the data set was collected from the HFSS. Then this data set have used to run the model and forecast that if SO11 value for it. So the parameter provide that lowest SO11 value will then actually chosen. So here, a based model, they have chosen that lowest that are where the MAC value is the lowest. So they have the fabricated the antenna also, and they confirm that frequency range lies between the 2.9 to 21.6 gigahertz. It's a huge bandwidth. They obtain that frequency range is obtained is from 2.9 gigahertz to the 21.6 gigahertz. So in that reference number 35, that Singh et al. They also use the flame optimization they have used. And mainly this optimization they have applied in that ground plane. And they implement this algorithm in MATLAB. And they obtain the range 3.1 gigahertz to 10.6 hertz. So these are the basic features of that thing. They have even, I think they have already done that fabricated receivers. They have not fabricated only that. This is based on the simulation result only. So they actually design. They have used the substrate of the liquid crystal polymer, which is having the thickness of 2 millimeter, and they applied that MFO on the ground plane, as I told, and this operational bandwidth of the antenna having is a operating frequency, resonated frequency is basically 3.1 gigahertz, having a return loss of 20 dB, and it having that good covered is a very ultra wide band, the 3.1 gigahertz to 10.6 gigahertz. So also they have observed that if we increase the width of the patch, the bandwidth increases, but the impedance of the patch antenna get reduces. So these are the observation by that thing at all. Then in the George et al. In the reference number of 36, this is also the fabricated result. This is not a simulated result. So this design, they have basically used that C-Leon optimization algorithm. Uh, this optimization technique they have utilized. It actually used in that WSN network, that wireless sensor network. And here, if you see, they have introduced that slot, that L type of slot within the patch, that the patch length and width, the ground length, the width of the L shape of the slot parameter, then feed line length and width. These are all parameter on which you have to do the parametric analysis. Then they can obtain that optimized bandwidth and resonant frequency. So for that purposes, they have used that Python to implement C-line optimization algorithm. And they have also for antenna design, they have utilized that HFSS for data set generation. Here, another example of that of reference number of 37. That author is basically again utilizing, they have designed a wideband PIFA antenna where they have utilized the genetic algorithm. So what are the parameter? What are the they have utilizing that resonating frequency, radiation pattern, gain, VSWR. So these are all characteristics of the antenna. So they have changed the different. What are the algorithm they have used? The genetic algorithm they have used, as well as mainly genetic algorithm they have used. So this is one of the complicated structure they have done, and another structure is also the chip patch antenna that et al. Proposed in the 2020. So they have utilized that mutation probability based algorithm. This algorithm they have used, and again this algorithm they have compared with the different other algorithms like ABC algorithm, PSO, then GW. So they have compared, and they showed that they are proposed algorithm having the better efficiency and better coverage rate. So these are about this antenna they have utilized. So another, this is one of the patch antenna, which is basically butterfly shaped patch antenna. They have also used that multi-species particle swarm optimization. So with the combination of MATLAB and HFSS software, they have done the optimization data. Here also they have given fabricated result and simulated result. If we see that almost it is similar pattern or similar result they are giving. Here if you see that comparatively here that what are the parameter they have considered, mainly the width of the W and length of that microstrip line exciting to the antenna, the inner and outer radius of the both metallic loops forming. So these are all parameters which they have considered and for doing the optimization. In the Sarkar et al. In 2020, they have also proposed that ultra wideband antenna with U-shaped slot, which having a frequency reject that 3.7 to 4.2 gigahertz. So this they have used the artificial neural network model, which is basically using the different algorithm like L, MBF. So they have used the MATLAB. So they have also fabricated the results. So these are the different type. Here only I have demonstrated, I think 10 paper where they have utilized the many algorithm and they got that optimum result for getting the better result. So based on the literature survey, what we found that what are the challenges or uh, what are the challenges for the antenna design and how we can mitigate by using those challenges. So as we know that if uh, we can get that broadband behavior when basically two or more resonance are accessible to each other, then they used to superimpose and then it is used to increase the bandwidth of the antenna. So suppose we are going to use the thicker substrate. So it's basically increase that radiating power and it used to reduce the conductor loss. This is one of the good thing. But if we are going to, and automatically it will increase the impedance bandwidth of the antenna, which is also basically proportional to the thickness of the substrate. So it's a good thing if we increase that. But the thing is, the conflict is basically what happened that if we increase the bandwidth by increase of that thickness of the substrate, then automatically you have to reduce the surface waves also, the decreasing of the thickness of the substrate. So automatically, if we increase the substrate thickness, automatically we are going to increase that surface wave. So we have to compromise in between. So we have to think about. So the high diameter substrate is decreases antenna because the dimension are inversely proportional to the dielectric constant. So here, based on this algorithm, what we can see, these are the possibilities of what we can think about that to design a wideband antenna, which having that high to means we have to reduce the antenna size. Then we can think about dimension of the antenna with great impact on the gain of the cattle. So small gain is provided via low profile antenna. Gain improvement also required to implement. So for doing on all optimization, we can utilize the different ML algorithm like in algorithm or regression analysis or ANOVA, etc. can be incorporated. And also we can modify that optimization, like we can apply the different hybrid technique to get the optimized results. Um, things. So what are the with all discussion basically for implement machine learning, we require that quite large data set. So it's a difficult task, but still people are working on it. So it depends upon the particular antenna. It's not like that data set is markedly available. So automatically you have to create your data. So afterward, only you can design a model, and by using that model, you can get the optimal result or optimal characteristics of the antenna, or you can design an antenna with small size and getting that highest value of characteristics, the characteristics feature. So, like here, we can see here in this lecture, today I'm going to discuss about that advantage of the mid-band 6G, mainly FRC band, uh, that we are on and how to create the low-cost, small, high-gain, wide band antenna, that what are the different solution to get or to design this type of antenna. Also, we have learned about the many machine learning algorithm that which is basically going to be help to optimize the antenna parameter and antenna performance. So in many method we have gone through like AN, PSO, GWA, GA, ACO. So all are the different algorithms. So people are using the different algorithm to obtain, and they are also comparing with the existing algorithm that what particular algorithm will be beneficial for that particular antenna design. So these are the content which I covered today. These are my all references list. So thank you. Now, if you have any question, please.
Ma'am, the participant has asked, can you show a small example how to generate data, then PSO to optimize any antenna? It will be beneficial for us.
Okay, so I will share with the brief step-by-step procedure in the PCO, and if you share that particular mail address of the participant, so by today itself I will share that what are the basic steps are involved for doing.
Okay, ma'am. Participants can ask the query. If you have any doubt, please you can ask. Ma'am, I think no more queries are there.
If you have any doubts, you can pin me my mail address choitali.ec @nitmj.ac.in. Um, Even if you are a particular question, so you can WhatsApp me also in my number, that is 8794 620464. Okay, so I will respond soon. Okay. Um, okay, then thank you all
Thank
for
you.
attending my lecture.
Thank you, ma'am.
I understand it's a quite boring type of lecture because majority are optimization technique. My emphasis is on the optimization technique. So I hope it will be, and already I share that content with Sarthak sir. So I hope that Sarthak sir will share all the documents. So from her also you can get all the details.
Thank,
Thank you very much.
thank you, ma'am. Thank you very much. Dear participants, next session will start from 11 a.m. You are requested to kindly join by 10:45.